Hey y'all, today we're going to put those theorems that we've been talking about, those triangle congruence theorems, and we're going to put them into practice in what we call proof. So we're going to write two-column proofs, and they're called two-column proofs because we're going to have two columns. One column is going to be full of statements, things that we're saying are true about a picture. And then the other column next to it is going to be reasons, and those are the reasons that we're allowed to say those things about the picture. And each statement is going to correspond to each reason. So statement 1 is going to have reason number 1, statement 2 will be justified by reason number 2, and so on and so forth. And there's no set number of statements and reasons. It's just all about what does it take to prove whatever you're trying to prove, and I'll elaborate on that using an example. Ours are going to tend to be a little bit shorter in this class, but just know that proofs can get long. So we've seen a picture like this before, and I would have asked you which theorem proves that triangle ABC is congruent to triangle ADC, and you might have told me angle, side, angle, and that's because we can draw that little slash there because this side is in both triangles, and you might say that that's because of the reflexive property, and then also that this side is between each of the angles in each triangle, so that means that they're congruent by angle, side, angle. So that's more of an informal way of proving that these two triangles are congruent. When we write a proof, that's a formal way of showing that, and that's sort of what we've been heading into here. So whenever I have a picture or I'm trying to write a proof, I'm always going to have some information that's been given to me. Either I'll write it or I'll put it on the picture. So right now I have two pairs of angles that are congruent. I have BCA and DCA are congruent, and also BAC and DAC are congruent, and that's what those little red arcs mean. So that's always going to be my first statement. The stuff on the picture that's given to me, or sometimes it'll just be written and it'll say given, and I'll be given this information. That's the first thing I'm always going to write. And then the reason that I'm allowed to say that about this picture is because it was given to me. It's on the picture, or I was told that it was true. So I'm always allowed to use that information to make this proof. And at the end of this, my goal is to show that these two triangles are congruent, meaning that all the sides are congruent and all the corresponding angles are congruent. The other thing I did here was at the beginning of this, in my explanation, I put that little mark there. That's not something that was given to me, but it's something I'm allowed to say, and I'm allowed to say that segment AC is congruent to segment AC because of that reflexive property that we talked about a few lessons ago. So that mark was not something that was in the picture already, but I'm allowed to draw it, and I can draw it because I know that if two triangles share the same side, they're equal, and that's the reflexive property, so I can say that. And my end goal at the beginning of this proof was to use angle, side, angle, and I can make a conclusion using angle, side, angle if I have two pairs of angles congruent, and I've written that in my proof, which I have right here in red, and also the side between those angles, I've written that. So I've written in my proof that two pairs of angles are congruent, the sides between them are congruent. So that's enough for me to say that these two triangles are congruent. And my reason I can say that is angle, side, angle. So essentially this is a long-winded way, or a long-written way to do what we have been doing. It's just the organization that takes some practice. So we're going to do some more together. So I'm given a couple things in this picture. I'm given this side ML congruent to this side PN. And I can say that LP is congruent to LP by the reflexive property, those two sides. And I think probably at the beginning of this, if I just said which theorem, you might have said side, angle, side. So my goal is to show these two triangles congruent by side, angle, side. I need to say that MLP is congruent to NPL. The reason I'm writing this in green is because I just need to be thorough. These show me that those angles are 90, but I need to say that because they're 90, then they're equal. And I can say all right angles are congruent. That's sort of a thing that will show up in a bunch of problems. So I wanted to say side, angle, side. I have a pair of sides here that were given to me. I have a pair of sides that I found by using reflexive property. And now I have these angles that I said are congruent because they're both right angles, and all right angles are congruent. So now I can say the triangles are congruent, and my reason is the side, angle, side theorem. We're going to do a couple more together, and then we'll have plenty of time to practice in class. So I have a couple things given to me in this picture. I have segment QP and segment ST congruent. And then I have this angle QPR and angle TSR are congruent. And those are shown to me in the picture, so they're given to me so I can say they're true. And then I have this other thing that we've used. These angles right here are vertical angles. I'm allowed to say that they're equal. I just have to write it, and I have to justify it. So I can say QRP is congruent to angle TRS, and my justification, my reason, is that they're vertical angles. So now I have two pairs of angles and a pair of sides, and those sides are not between the angles. I can still say the triangles are congruent, and now my reason is angle, angle, side. This is the last one. We'll do it together. There's no pause and try today. There'll be plenty to try in class. I'm given two pairs of sides that are congruent, GI and HJ, and GH and IJ. And again, my first statement and my first reason are always the things that are given to me, and the reason for that is that they're given to me. I'm allowed to say what I'm told is true. You might look at this and see that there's a third side, so my goal is to use side, 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 but I have to say something about that side. I have to say that HI is congruent to itself. And that's my famous reflexive property. So now that I've written three pairs of sides that are congruent, I can say the triangles are congruent, and I can say they're congruent by the side, side, side theorem. So I should have pointed out, and I'll point out now, that in every single proof, whenever you write a proof, once you say the thing that you were asked to prove, that will be your last statement. So the first and last statement are pretty easy to get. The first statement is the stuff that you're told is true. The last statement is the thing that you're trying to prove. So once you've shown the two triangles congruent, you're done with the proof. That's the end. That was the goal. So it would be pretty hard for me to have you put this into a Google form. So to show that you've done your job and to get 100%, type the word bumblebee into the answer box and submit it on the Google form, and you'll get the 25%, and you'll get the 75% for your notes in class.